All right, good afternoon, people joining today. I think we'll get this one kick-started. So it has been recorded for people that want to, so people can catch up with this later. So welcome to episode 6 of the Brevity Technical Webinar Series. We've got another exciting one to kickstart 2024. This is called Seismic Assessment of Existing Secondary Elements. It's a fairly hot topic, something that we at Brevity come across quite often. And today I've got Suri. Suri is one of our professional engineers who has 5 years experience with the company, joining myself as new business lead. So let's kickstart the webinar. And if this is your first time joining, Slido may be new to you, but if you're a regular, you would have seen this before. So essentially, we are going to be using Slido as an interactive way to get to know the audience, and we'll also use it for the Q&A session at the end. So if you can get your phones out, use the QR code on the screen there. It'll take you to a pop-up window where we will be doing 2 quick polls to just get a feel for the audience members joining today. I'll go to the first poll because that QR code will remain there. So the first one is, which city or country are you dialing in from today? Looks like we've got 5 participants. We've got Auckland, Australia. Always good to have some of our friends from across the Tas. Auckland seems popular. North Island, 31A Drake Street. You can be as specific as you want. So it looks like we've got Hamilton as well. Fantastic. It'd be pretty cool if someone joined from Europe or somewhere unusual. So it's mostly New Zealand with a bit of Australia. And the next poll is, what part of the industry are you associated with? So tell us if you're an engineer, or you might be from council, you might be an installer. Let's get a vibe there. Engineering, engineer. Engineer seems pretty popular. Detailed seismic assessment does sort of pop out as a common thing in engineering. We've got supply, sales. Fantastic. We've got a slight mix there. The engineer seems to be the most popular. So again, we'll jump into our main slides here. This is just a 15-minute quick presentation or webinar. We've got time afterwards to do the question and answers. So if you have any questions, you're welcome to add it on the phone. You'll see a Q&A part, and we will go through those at the end. So let's kickstart the main portion of this presentation. So what is a detailed seismic assessment? We've got a few engineers joining in today, so I'm sure they would have heard of a DSA, it's often referred to as. So it's essentially a quantitative procedure to help assess existing buildings and elements. So it's helpful for engineers because it provides a framework and a method. It's also helpful for building owners, or maybe not so helpful because it puts a bit of pressure on them to make sure their building is not earthquake prone. And it's also helpful for the TAs and building council authorities to help understand and manage seismic risk when it comes to buildings. So you might be thinking, this is all very good, but why is it needed? Well, it's needed because it does fall into the Building Act. And so the earthquake-prone building provisions, which were created by the Ministry of Business, Innovation and Employment, These came into effect in, I think it was 2017, there were guidelines and different assessment procedures that are detailed to help identify essentially whether a building is at risk for earthquakes. And the main part of the assessments, it's split into 3 different parts: a part A, a C, a B, and a C. And we will be talking about mostly part C, which is the detailed seismic assessment. Part A is associated to the initial seismic assessments. And if I jump to the next slide, this is where we've got the terminologies, which often we do get a few requests with clients asking to clarify what these different terminologies are. So let's just quickly cover them now. So an initial seismic assessment, the ISA, that falls under part A of those provisions. And it's essentially the first look, the first check at what the likely performance of a building, or it can be broken down into smaller parts, is. And it's a very holistic view and like an overview, which it's the best starting spot. And then that can flow into a detailed seismic assessment, which we're hoping to discuss today. And that's a more qualitative, to confirm earthquake rating with a higher degree of reliability and what the next steps can be there. Another common term is an earthquake score, which is very similar to, or it aligns quite well with percent MBS. And that is an indicator for either the building, or it can be broken down into individual elements to indicate the seismic standard, which takes into account the human life safety, and Suri will be talking about that soon. And it compares it as a percentage. It compares the existing building to that of a similar new building designed to the current codes and standards. So you see the percent MBS term thrown around on the news quite often. What's a non-structural element? So essentially, it's an element that is not part of the primary structure. And that's where commercial interiors will fall into. So your suspended ceilings, partitions, and like your suspended surfaces are treated as non-structural elements. There's also a space class. So this is fairly important for commercial interior when you're looking at the elements, and that's a classification of a particular space based on the functional purpose and hazard. So Suri will be taking it away from here. I'll hand it over to you, Suri, to do the next few slides.
Thank you, Joe. Welcome, everybody. Yeah, so what does this mean for commercial interiors? Secondary structural and non-structural elements, like SSNS, like if you had to make it into an abbreviation, is basically requires a classification into space classes in order to categorize them into life safety risk. So why are we doing this? We're basically trying for existing buildings, making sure that the life safety risk of the elements inside that building are minimum to none or low. The way you can do this is basically have a space class attached to each area in the building. That actually helps us to be like, okay, these are the elements, which elements we should probably take into consideration for our ISA and DSA, which elements can be omitted or which are not as critical. So space class 1, 2, 3, 4, 5. So it ranges from these 5 different categories, going from high risk of space class 1, which basically means any pathways to egress route. In case of a seismic event, people have to use those paths quite frequently and anywhere a lot of people gather around. To number 5, space class 5, which are basically no one uses these areas as much. So let's say like a frozen section, only a few people might be in there in case a seismic event does happen. We usually generally require space classes or we require seismic design for space classes 1, 2, and 4, which is VADS. 3 is also a part of it, but I'll discuss that later as to why, when to use 3 and when to use 4, but that's about it. The way you would do this is, what we're trying to achieve is trying to achieve low risk for those elements. Here you can see that the percentage NBS is basically, it is very hard to determine how well an existing building can be compared to a new building. And that's where the new building standard percentage comes into play, where you're basically comparing as to, if you had to compare this existing building to a new building, what percentage of this is okay if it was to be designed in this age, and like if it was made this year, the new building. So like a 67% NBS building is still has about 2 to 5% times the risk of a new building, but we're trying to minimize the life safety risk. So what we do is basically we do an ISA, determine all the elements that might be high risk, very high risk, medium risk, and try to bring it down to low to medium risk. And that can be shown in the graph there. That shows the relation between seismic rating and the level of shaking and the earthquakes and stuff, and how much loading there is. And we are always trying to be in the green area, just above the yellow line. Yes, next slide, please, Jai. So the risk is determined by space classes as well as the type of elements that you'll be using. So for example, let's say a ceiling system or a partition system. There's 2 tables here. You can see there's 2 columns in the table that show when it is expected to be a life safety hazard and when it is not going to be a significant life safety hazard. The first one is heavy ceilings, or any ceilings that are above certain space classes, or you've got like ceiling tiles above 7.5 kgs. While if ceiling tiles are less than 7.5 kgs, then it might not be classified. So you can see that if it is the same ceiling grid but different types of ceiling tile, it has a different outcome in when it is going to be used to be an element to design, or when it's not. So yeah, like it's not very black and white in the way you would actually design and do a DSA. So like ceiling spaces, that the same ceiling, like heavy ceilings in a space class 5, you might not even look into that. It might not be as much of a risk as compared to a light to medium ceiling in a egress pathway like space class 1. And yeah, next slide. Sorry.
Thank you, Suri. Hopefully that explained the sort of a summary of the key parameters used for us as an engineering consultancy to be able to do the DSA process. Because this is a 15-minute short and sharp webinar, we're already into the key takeaways here. So 3 points. DSAs, they do provide useful information to assist building owners and TAs and councils to decide on the next steps for existing buildings, and particularly those that are earthquake prone. And it's also a tool that we use as a commercial interiors engineering consultancy for the non-structural elements. The second point there, existing commercial interior elements, they do need to be considered on a case-by-case basis, similar to what Suri was just talking about. And it depends on the class, space classification and the part type. Like Suri was saying with the ceilings, it may depend on the weight of the individual elements. So it's not quite as black and white, but there are good engineering procedures in place to do an assessment. And the final point there, for commercial interior elements, the cost is actually comparatively minimal to increase those elements from the minimum 67% NBS up to 100% of the new building standard code. And that's a little different to structural elements, where the cost may be significantly more to not just meet the minimum requirement, but to meet the 100%, or you could even choose to go and exceed the current code requirements. So hopefully that has maybe answered some of your questions, or some of the hot sort of topics that pop up when you hear DSAs. We are keen to get feedback, and we're here to answer any of your questions. So it looks like one's already come in. And if anyone has any more questions, please do fire away, and we'll see how many we can answer in the time we have here. So the first question there, I can make a start on this, sorry. So what's the time frame for needing to meet a certain percent MBS? That's a great question. So the whole, as we mentioned earlier on, the earthquake prone buildings came into effect around 2017, and the time frames needed, it depended on whether the building was a priority, like maybe schools fall into the priority side, and the seismic risk associated with it. So it, from memory, it was like the timeframes needed were sort of like it was around 7 years up to around 30 years, depending on those two factors. So we can look into that standard and give the exact years needed for those. Sorry, if
There's another one. Yeah. So why is it 67% NBS minimum? I think that's a great question. It's trying to be low life safety risk, and when you compare it in the graph that we just shown, isn't like 67% is where the risk starts to being low, and that's why it's like considered as 67 as low. Like everything above it is like low risk, anything below it is like medium, then high, very high. That's a good question.
I just going back to that first one, I just looked up in the guidelines there. On top of the DSA part of it, it says that there were timeframes for the initial seismic assessments, and those dates have actually already been and gone. So if your building was in a high seismic risk, an ISA needed to be completed by the start of 2020, and for medium risk areas it was mid 2022, and there was no ISA deadline date for the low risk areas. It's handy having the information just at your fingertips. And if you do have more questions that you want answered after this, feel free to reach out to us on LinkedIn, or you can definitely send us an email, info@teambrevity.com, and we'll make sure to get back to you. We'll give it a little more. Some people might be about to type something in. But I am excited about our next webinar, so that's a good time to talk about that. So that will be in 3 weeks' time. The topic is about to be released, and it is to do with BIM. So if that is something you're interested in, keep an eye out for that one. Right, team, we might be calling it there, I think. Thank you to Suri for co-hosting this one. It's been a pleasure having you.
Thank you, Joe.
And we'll call it a wrap on episode 6, and we hope to see people dial in for episode 7 in a few weeks' time. Have a good rest of your day.
You guys, see you.